We're going to be looking at even and odd functions, and we're just going to be noticing and wondering some of the differences between these two functions, and then summarizing what makes a function even, or what makes a function odd, or what makes a function neither even or odd. So first I'm going to start with clearing up a misconception. In Algebra 2, you talked about the end behavior and the degree of a function. That's a highest exponent. And it was probably summarized that if a function has an even degree, like in y equals x squared, that function would have the end behavior and that the ends are going in the same direction off to infinity. That is true if the degree is even. That is not what necessarily makes a function even, okay? Or you learned in Algebra 2 that if a degree is odd, that the function would have the end behaviors going in opposite direction, like you see here with x cubed, and cubed is an odd degree. The highest exponent is odd. Those rules deal with the degree of the function, the highest exponent. There's actually more to the definition on whether or not a function is even or odd. So I'm going to ask that you just do some noticing and wondering. I'm going to give you a set of even and odd graphs. Here's a set of even. I want you to list as many things that you can think of that these functions have in common. Now would be a great time to pause the video and give your brain some individual processing time. Allow this information to just soak in, just notice and wonder. That's how you're really going to learn. Okay, here's some questions you might want to ask yourself. Are the even graphs symmetric, and over what line? If the graph passes through A comma B, what point must it also pass through? So over here, A comma B might be the point 2 comma 4. What other point must it also pass through? If you shift the graph left or right, is it still even? Or if you shift the graph up and down, is it still even? So these are all questions I want you to think about and make a conjecture on what you think. Again, pausing the video to give your brain some time to think is a great option if you're here to actually learn. I'm going to do the same thing looking at odd functions. These are 3 odd functions. Again, I want you to list as many things you can think of that these functions have in common. Maybe answer some of these questions. Again, is it symmetric over a line or a point? If you rotate 180 degrees over the origin is at 0, 0, right in the center, what happens? If it passes through A, B, so like point 1, 1, what point must it also pass through? If you shift the graph left and right, is it still odd? Or if you shift the graph up and down, is it still odd? These are things I want you to reflect on before moving forward. Give your brain time to simmer on these questions and these ideas. So moving forward, we are going to summarize what we're seeing graphically. So graphically, if you think back to those examples we were just looking at, all of those graphs were symmetrical over the x-axis, over the y-axis, the vertical axis. Let's go back here to the function y equals x squared. If I'm looking at this quadratic, it is in fact an even function, and if I would fold the graph along the y-axis, my arrow is pointing to the y-axis, if I would fold the graph along the y-axis, it would be a mirror image. It would be symmetric along that vertical axis. In words, what we're saying is that the output is the same regardless if you put in a positive or the negative x value. Okay, so the output ends up being the same regardless if I put in a positive x or a negative x. So let's look at the graph. So let's say I input a positive 2. My output is 4. Now let's input the opposite, which would be a negative 2. So I'm going to go over here. I input a negative 2. I still get an output of a positive 4. So if I input a positive 2, I get positive 4. If I input a negative 2, I get a positive 4. This is a characteristic of an even function. So let's look at what that is symbolically. If I put in f of x and I input f of negative x, I will get the same output, the same y value. Think back to what we just did and think of this notation. If I input f of negative 2, f of 2, and I input f of negative 2, I get the same output, which is 4. That is what makes something an even function. So like we just said, f of x equals x squared is an even function. But what transformation will make it no longer even? So I want us to think about this. I'm going to go back to Desmos here. Let's explore some transformations. If I take x squared and I just shift up 3. Let's shift up 3. Does it still hold true that when I input a value, let's stick with 2. So now when I input 2, if I can get it right on 2, I get an output of 7. Let's go over to negative 2. If I input a negative 2, will I still get an output of 7? Yes. So the vertical shift still works. Let's try a horizontal shift. So now I'm going to do x. Let's do minus 3. Now I'm shifted to the right. So now when I input, I don't have that symmetry anymore. I can't even see negative 2. So if I input 2, I'm over here trying to get there. At 1, if I input negative 2, man, I'm going to really have to scroll out to even see negative 2 on my function. So this is no longer symmetrical with that vertical axis. So the horizontal shift will no longer allow for the function to be even. One more function, even function, or one more function we're going to look at is f of x equals the square root of x squared minus 6. So I've got this already plugged into Desmos. Graphically, it does look like it's symmetric with that y-axis. So graphically, I'm already seeing, okay, this does look like an even function. Let's think about it algebraically. Let's say I substitute in negative x. Well, if I substitute in a negative x, I get negative x squared minus 6. Well, what happens to this negative x when you square it? It is the same as a positive x squared. So this will still equal, even though I'm inputting negative x, I'm going to get the same exact value as if I would have inputted a positive x, making this function even. So yes, this function is even. Let's wrap it up and look at odd functions and our summary for odd functions. So graphically, we're going to have a 180-degree rotation about the origin. And maybe you saw that in our notice and wonder. So if I look at my graph, here I'm going to look at 1. If I input 1, I get an output of 1. But if I input a negative 1, this graph is going to rotate around 180 degrees around that origin. So if I input a -1, I also get out a -1. So what makes something an odd function is when you input the opposite value, you get the opposite output. Symbolically, what does that look like? If I input -x, I'm going to get an output that is opposite. Let's explore another odd function. Sine of x is actually an odd function. Let's look at Desmos one more time. And I'm going to change the scale. If you don't have Desmos, I highly recommend getting Desmos. It's a free app. It's really fantastic. You can change your axis. So if you notice what I'm doing over here, I'm changing my axis to be in terms of pi. I'm going to do a step of pi over 4. And so now my x-axis is labeled in terms of pi. How great is that? Okay, so I can see my entire function in terms of pi. You can play with the axis quite a bit. So what we're looking at with this odd function, if I input pi over 2, I get a value of 1. The sine function is at its maximum at pi over 2. But if I input a negative pi over 2, so I'm going to scroll along backwards to a negative pi over 2, I get a -1 as my output. And so let's think about if I transform this, if I make this a negative sine of x, is this still odd? Well, now I look at pi over 2, my output's a -1. If this function is still odd, then when I scroll along to to a negative pi over 2, my output's now a +1. My opposite inputs will yield opposite outputs. Let me say that one more time. My opposite inputs, negative pi over 2 is opposite of pi over 2. My opposite inputs will yield opposite outputs. That makes something an odd function. So therefore, if I plug in a sine of -x, the answer will be the negative of sine positive x. Let's wrap this up. Is this function odd? Well, one, it's a quadratic function. So no, one way we can verify this is if I input -x, the algebra is going to reveal that I don't get the opposite of the original function. When I input a -x, I get -x squared, which actually is just a positive x squared. And then this value over here is going to become a positive 2x. And that's supposed to say a +1. So I know that was a lot to take in a video. We're almost at 14 minutes, but I hope this was helpful for understanding the difference between an even and an odd function. Thanks for watching.